Hi there, this is your favorite non-Indian math channel and I have an integral problem for you. So usually it's if you have something like that you can't really find the antiderivative and it's trigonometric function, you should keep in mind that there is a substitution. It's really useful. Tangent x over 2 is equal to u. Well, if you don't know this substitution, it's really hard to come up with that. But you should keep in mind, okay, if you have something complicated at the denominator that is trigonometric, you can use it. So let's draw a triangle and see what this cosine x is going to be. So I know that x over 2, if I take tangent of it, so it's going to be u, and tangent is this thing over this thing. So this is u, this is 1. And so by the Pythagoras theorem, I can say this is u squared plus 1. Okay, cool. So I can find what is cosine of x over 2. So it's going to be 1 over this thing. And, well, to find cosine x, we need to know what is double angle formula. So it's going to be 2 cosine squared x over 2. You need to know trigonometry well, okay? 2 cosine squared x over 2 minus 1. Therefore, so we can just substitute it in. It's going to be 2 cosine 2 times this thing squared. So it's going to be 2 over u squared plus 1 minus 1. Let's not do it on this step because I want 2 plus cosine x. So 2 plus cosine x. So I'm adding 2 to this thing. It's going to be plus 1. 2 over u squared plus 1 plus 1. And it's going to be u squared plus 3 over u squared plus 1. Okay, so I know what is 2 plus cosine x. So I also need dx. So let's integrate both sides here. I know that the derivative of tangent is secant squared, which is 1 over cosine squared. And by the chain rule, I will also get 1 over 2. So it's going to be 1 over cosine squared x over 2 dx is equal to du. So I know that this is cosine squared x over 2 is going to be 1 over u squared plus 1. So it's at the denominator. Then u squared plus 1 is going to be at the denominator here. So I'm just going to divide it by that and multiply both sides by 2. So dx is going to be 2 over u squared plus 1 du. So let's name our integral I and continue. So I know what is dx and what is the denominator, 2 plus cosine x. So if I just put them in, I is going to be equal to, so I have this thing, I have 2, let's write it outside. I have 1 over u squared plus 1. And I have this thing, so I'm going to flip it because it's at the denominator, u squared plus 1 over u squared plus 3 du. Okay, well, we are lucky. These two will cancel out. And the integral is going to be 1 over u squared plus 3 du. And here you can either just directly say, so this is square root of 3 squared. And you can directly use the arctangent formula, or you can make a substitution, okay? So you can just divide both sides by square root of 3 to get it in the form like 1 plus u squared, 1 plus something squared, okay? So I can say it's just 2, and so I'm taking this part into 3 parentheses, okay? So I'm taking 3 out, and then it's just gonna be 1 over, so it's gonna be u over square root of 3 squared plus 1. And now I can make substitution and say u over square root of 3 is, let's say, v. So if I differentiate both sides, it's going to be 1 over square root of 3. du is just dv. Well, I don't have this times du, so it's just going to be square root of 3 dv. Okay, so it's going to be, so I'm multiplying this thing by square root of 3, so it's going to be 2 over square root of 3 and 1 plus 1 over 1 plus v squared dv. And so this is just going to be 2 over square root of 3 arctangent of v and arctangent of, so this w is just equal to this thing, so let's say u over square root of 3 plus c. And I also need to substitute u, so I said u was equal to tangent x over 2. So I'm just gonna put, instead of u, I will put tangent x over 2. Also here you should be careful. If you had only, sorry, this is wrong. So this is tangent x over 2. So I put this instead of u, square root of 3. So here you should be careful. See, I wasn't careful. You can simply simplify. Oh, I have arctangent and tangent, so it's going to be x over 2. You can. If there was no square root of 3 here, you could say that, and you could say this whole thing is just x over 2. But since you have something divided here, this is not equal to that. Okay, so this is the simplest form answer.